Okay, let's create ourselves a pulse generator. We have a clean slate set up in the multi-sim software. So let's place some parts first. Place component, and we have the inverter set up, but let's just start with the AND gate. All right, so what we have here, okay, I'm just going to clean the whole thing up and start fresh. All right, place component, and all groups, master database, that's fine. Here's the search window, and let's get ourselves an AND gate. So type A and D, and that gives us choices for some AND gates. All right, so let's just take a 2-input AND gate and click OK, and we can place this anywhere we want. For now, we're just going to place it right in the middle here. All right, what else do we need? We need an inverter. All right, an inverter is a NOT gate, so you can just go N-O-T, so NOT gate, that gives us inverter. All right, so here's an inverter, 1, 2, and 3. Okay, we're going to use 3 inverters. What else do we need? We need a resistor. Let's grab a resistor here. So I'm just going to erase this here. And from here, for this groups, all groups tab here, I'm going to press that, and I'm going to select basic group of basic components, and the resistor should be somewhere here. There it is. All right, I'm just going to grab any value of the resistor, place it for now. And we will need a push button switch. So let's just clear all the groups, make it okay, make it all groups. And push button in the search window, you can just type here push button, so PB. That's how you find the push button switch on the multisim. So PB, and that gives us choices of which one do we need. We want push button switch normally open. That's what it looks like. All right, let's just grab it and place it somewhere here. We always need a ground, so let's just go again, erase the search window so we don't have any pollution happening here. And from the what was I going to get? Okay, from the group, we're going to get sources. That's where the ground lives. Sources, and I think it's in power sources. Here is ground. Okay. Ground, here's a symbol for the ground. All right, let's just place that one here, and we also, let's just grab ourselves a VCC. All right, collector source, sources, power sources, there you go, and VCC is somewhere here. We could just grab a battery that DC power, and we can set up the voltage to 5 volts. But it's just the same as we're going to grab VCC. It's just going to be cleaner on this screen here. So click OK. So VCC selected, click OK, and place it somewhere here. It shows us VCC of 5 volts. And let's just start assembling things. So I'm going to cancel out from the component choice window. All right, so let's just put all those here. All this here for to our left, and start assembling things. So we will need VCC, we will need a resistor, and we need a push button switch. So let's just we might want to rotate that. So I'm going to click on that resistor once. The little dotted line appears, and I'm going to hold Control and press the letter R, the key R, and it's going to rotate. As every time I press it, it's going to rotate that 90 degrees. We want this thing in this position here. All right, so okay, we're going to put it right somewhere. Let's say we can rearrange it if we need to. So for now, we're going to have that, and instead of 1 kilo ohm, we might just adjust the value of it. So double click on this now, or you can just right click on it and select properties. It's going to give you the same thing, and from the properties it shows us the resistor, label, that's fine, nothing, we're not going to change anything here. display, nothing here. Let's go value. All right, and here's the value, and it's ohms, tolerance 0%, so it's a pretty clean resistor here. All right, it pretty much doesn't exist in the world, but this is a software here, so we can afford that kind of provocation, if you will. Anyways, so highlight the whole value here. This one shows 1K, so it sets for 1 kilo ohm, which means it's 1000 ohms. But for this one here, we're going to select 470, and we're not going to get any designations after that. So that's 470 ohms, and watch, this value is going to change as I press OK. Alright, there we go, 470 ohms, and that resistor is going to be connected right to the ground. So might as well place that, and I'm going to zoom in a little bit. We can connect that. As soon as I mouse over that lead of the resistor, the cursor changes, which means if I click on it, I'm going to place a line. Clicked on it, and the line is activated, so I'm just moving the mouse without pressing anything, and I'm going to bring it up to here and click again. So that means we have this side of this resistor connected to the ground. And I'm just going to use the wheelie of my mouse. This is how multisim works. You just use the wheelie of your mouse to zoom in and out. And now what we can do is we can select this push button switch here and bring it right somewhere here. Okay, let's we might as well bring it a little bit higher, right? Or not, somewhere in the middle for now. So I'm just going to bring that into connect one side of the switch to VCC, and I'm going to move that resistor here and move the ground as well, and I'm going to connect that part here. All right. So now we can rearrange the labels here, so to make this thing a little cleaner, or we can just double click on that and make this thing not display. The key equals space. That means if you press space, you're going to activate the switch. See what happens. But I'm going to press space. The problem with this in multisim, if you press space, it just locks that switch into position. So we are not going to use space to operate that switch. We're going to use a mouse. Alright, so if we press a mouse, it's a push button switch, momentary push button switch. So click it, and it's just momentary pushes itself for us. Okay, now double click on that and choose display values here, and this is the use the sheet visibility settings. So basically that's the default, but you can just select this radial button, and all the menu just lit up. All right, so you can just deselect everything and click OK, and that is just going to be a switch. But let's just show labels. Is that going to give us? No. Labels values, I think, is this one here. No. No values. Let's keep going. Yeah, that's what we want. We just want to switch one. So I'm going to zoom in, click on just that label, and if you move your mouse, it's going to give you the grid, the placement according to the grid. Or if you click on it, oops, here, all right, and if you use the arrow keys, it's going to give you a little bit more precise placement if you want. Right? So you can just wheelie and move the mouse. Alright, so now what do we have at this point? We have created ourselves a pull-down switch, right? Pull-down switch, or a pull-down system. At this point, this is going to be our point here. So now whatever is going to be connected to this point, when the switch is not pressed, it's going to be pulled down to the low. So it's going to be logic level low or 0 volts here, right? As soon as we press this button here, we're going to get ourselves 5 volts at this point. Let's just confirm that. So in multisim we can get meters here. Here's the menu of different devices that we could use, and the very top one here, if you just mouse over it and stay there, it's going to show you what things are. So I'm just going to mouse over the multimeter, click on it, and now I'm just moving the mouse, not holding any buttons. I can place this multimeter anywhere I want. So let's say I'm going to put it right here. Okay, and now we're just confirming that. So here is the plus sign and the minus sign of the positive and the negative sign of the terminals of the multimeter. Now if you double click on that, you're going to get the display of the multimeter. Now you can select this thing to be an amp meter, you can select this thing to be a voltmeter, you can select this thing to be a ohm meter, and there's that dB level meter as well. So but we're going to use that voltmeter. So this thing is highlighted, the V is highlighted, and we're not going to use AC setting, we're going to use the DC setting on this. Alright, so that is the display, and now what we're going to do, I'm just going to click away somewhere, I'm going to mouse over that, and I'm going to click on it and connect that right to here, click, see? And that we can connect on the other side of the resistor and click. So now we have the multimeter set to this point. We're just going to confirm what happens when we press the push button switch. So press it and nothing happens because we don't have the simulation running. So we need to press this green play button which says run, and that is going to activate the simulation. Alright, so let's just press that and see what happens on the display for us. Click. Alright, so it shows 0 volts, of course, because the push button is not pushed. And once we push this button, we are going to well, what do we expect? We expect that point to be directly connected to the 5 volts, so we should see 5 volts here. Let's check it out. I'm going to press and hold. Alright, that thing changes to 5 volts. When I release, it changes back to 0. Or if I press momentarily, it's going to have momentarily 5 volts, but this multimeter doesn't have enough time to react to that. Okay, so alright, so we have confirmed we have that our pull down system ready for us. Right, let's stop the simulation and get rid of our multimeter. So here this thing disappeared. I just clicked on it and pressed delete. Okay, now so we're going to select this AND gate, and let's just not have too much on the display. So we're going to double click on that, call the display values, they're already here, and we're just going to click that, click off, and show this reference designations. Click OK. That's U1. Alright, so that's fine. So if I'm going to be talking about this specific gate, I'm going to refer to this one as U1. That's good. Okay, I'm going to press it right here. Okay, now well, somewhere here for now. Right. Now if we get the inverter here and connect it as such that one of the input is going to be connected, one of the input of the AND gate is going to be connected to the output of this inverter, and that is going to be connected to that point which changes from 0 to 1 as the push button is pressed. Okay, and the other input of this excuse me, this AND gate is going to be connected also to the same point. But let's just clean things up a little bit. Double click here, just show the reference values, reference designations, just leave that one on, and now things are much cleaner. So now we're going to make a connection right here. Right? So that's good. Or we could just click on that line and delete that connection. We could do the same thing just by doing it like that. It's going to be the same thing. Alright, we can do that. I can select that and move it a little bit closer. Alright, now to make things a little bit cleaner. Now I have these two left. What is going to happen on the output here? Let's just get a probe. So I'm going to go place component, and we're going to erase that and bring it to the all groups, and from the all groups database here we're going to go to indicators. Do we have the indicators here somewhere? Buzzer. I can't seem to find that. It's there somewhere. Or do we? Oh no, actually, you know what? It's in the group here. So the indicators are in the group. So click on that and select the indicators group. Select that, and from here we have the choice, and we want not a buzzer, we want a probe. So see, once I select whatever I want to select here, we're going to have some choices of what particular component we want. So we're going to want probe, and then what kind of a probe? Just a probe, blue, a digital probe. Let's get a red probe. Okay, so that selected, this symbol appears here. I'm happy with that, and we are just going to place that somewhere right here. Okay, and close that. Now it shows us this probe is going to react. It's going to go high if it sees 2.5 volts. So we can just leave that X1, 2.5 volts. That's fine. Or we can just double click on that and choose what we want to select. I think this is values and reference value designations. So these two we're going to keep. But we don't want that. We just don't want the values. Let's get rid of the 2.5. We know this is going to show us high or low. Okay. Alright, so now we have that, and connect that to the output of this. Now we are ready to simulate this simple circuit. What can you expect to happen when we press this button? As the button stays either way, right now this is before the simulation happens, so I'm going to click this simulation and stop the simulation, so that basically it's the LED or the probe is at rest. Okay, so now what's going to happen as we press the button or as we release the button? As it is, so we have the VCC and it's not connected to anywhere else, so this point is going to be low, which means if there's a direct connection to the bottom input of this AND gate, we're going to have 0 here at this point. Right. Now the other input is connected to the same point but through an inverter, so if this is low, this is going to become high, so we're going to have a low and high, and the AND gate, that should give us low on the output, because AND gate works in such way that we have to have both of the inputs high in order for the output to be high. Any other combination, one of them 0, the other one high, the other one low, the other one high, doesn't matter. Or if both of them are low, we're going to always have low. As soon as both of them are high, we're going to see high here. So let's see what happens if we press we start simulating that. So no matter what we do, we're going to have low, because we're never going to have these 2 points the same, end up in the same way. If we have low here, we're going to have high here and low here. Nothing, right? If we have the other way, we're going to just flip the inputs. Also, not going to have both of them high, so this is going to be low. So where do we do that? Well, let's keep going with this. All right. So let's just start the simulation by pressing this play button. Okay, so the simulation is started. Okay, well, as we expected, we do have nothing here on the output now, or nothing. We have a low here on the output. Now, as soon as we press the button, I'm going to press and hold. All right, and we also have low, and then I'm going to release that button, and we also have low. I'm going to press the button again. Notice that the probe blinks for a second. There we go. See that? All right. When I press the button, the LED blinks. Why does it blink? Well, when we press and hold, that whole output is going to rest at 0. It's going to settle at 0, at a low, logic level low or 0. But because we have an inverter here, an inverter has something that's called a propagation delay, and that's going to be the time between there's a propagation delay that takes for the input to reach high, and it takes very short time, but it still takes time. Then from that one on the output, it also takes time to transition from high to low or from low to high. So we have a little bit of time on the input here, we have a little bit of time on the output here, and we also have the time for the signal to travel through. So that is going to add up to something. It's not going to be a long time, it's going to be in nanoseconds. However, that nanoseconds or 2 that is going to take from that, between that reaches whatever level, and for the signal to travel here, something's going to happen here. So when we press this button, this point is going to change from 0 to 1. Okay, it is sitting at 0 right now. So what do we have? 0 here, because the button is not pressed, so this is pulled down low. So we have a 0 here, which means after the inverter we have this thing sitting at 1. Okay, then as soon as we press the button, this point is going to change to 1 right away, and this point is going to take a little tiny bit of time to change it from 1 to 0, because this inverter is going to invert that. But for that little bit of time, tiny bit of time, both of the inputs for a very short moment are going to be high. Okay, so let's just see that. Okay, we see a little bit of a blink happening here, right? All right. Okay, so ladies and gentlemen, we just have created ourselves a pulse. Let's confirm what the pulse looks like. Now, what I'm going to do right now, I'm going to stop the simulation, and instead of making, I'm just going to delete that line, and I'm going to delete this connection here, select that line, delete, and we can just select the whole thing and move it a little bit sideways, and we're going to do something interesting. Now let's just get rid of all the displays, display values here. So this one here, okay, click everything off, everything off, everything off. All right, and so is this one here. Okay, we don't need to know the exact designations of that. So now we have a cleaner system. Now I'm going to connect those inverters in series. The reason why I'm doing this is that there is a tiny bit of delay here, propagation delay for the signal to reach from here to there, but it is very extremely short time. But adding those three, I'm just adding this delay to that delay to that delay, so I'm tripling the delay of that whole inverter system. And we also, as a result, because we have 3 inverters, we are still going to have inversion happening. So here signal is inverted, then inverted back to what it was, and then inverted again. So everything checks out. All right, so we're just going to connect the output of that one to the input of this, and then output of that one to the input of this bottom one. And let's see here what we can, I'm just going to select that and move it a little bit higher, the whole thing, just so we have things a little bit easier on us on the whole display. We only have so much room. Okay, and now I'm going to bring this whole system right here. I'll just give it a little bit of room here. So that is going to go to the input of that, and this is going to go to our pull down system input. So we have that 3 inverters system, just for the transition to take a little bit longer, right? And then of course this one goes right back to where it was. Okay, let's confirm that this thing works. We're going to have a little bit more clear blink right now. Starts the simulation, press the button. Okay, so the blink is a little bit more decisive. All right. Sometimes it still doesn't show. All right, so let's see what the pulse looks like. I'm just going to adjust the screen here. There you go, zoom out comfortably. What I'm going to do is I'm going to bring out oscilloscope. Right? But first I'm going to stop the simulation. Let's bring out oscilloscope. And the oscilloscope that we want is the Tektronix. Where is it? Tektronix oscilloscope, that one here. So click and bring it somewhere that is going to be easy for us to see. You know what? Yeah, that's good here. Right. Now, if we double click on that, we're going to get the whole oscilloscope picture, but let's just make some connections. So here's a ground connection, there's the I think there's the reference point here, or I'm just gonna have to confirm what this one exactly is, with the letter P. Okay. Now here we have channels 1, 2, 3, and 4. There's a 4-channel oscilloscope, and here's a trigger input. What we're going to do is going to use ground and the channel 1 for now. All right. Well, I think there's a test point here. In a real oscilloscope, there will be a test point with the square wave, so you could just adjust the signaling input. Right? Anyways, ground, we can connect to ground, so we're not going to run a whole wire here because things are going to get polluted. So we are going to have another ground. So what I can do is I can right-click on this one, I can copy, all right, and click somewhere else, and Control V or right click, and we can just paste it. All right, so here if we have that ground, and we just can connect it right up to here, right to the ground. And then channel 1 of the oscilloscope we're going to grab from here, and we're going to connect this thing to that point right here. Okay, right, good. Now we're going to try to measure the pulse, so we're going to capture the pulse. So just double click on this scope to get the settings. You see, I just double click on that, right? Double click, and the whole thing just appears. That's the oscilloscope. And you know, it's just like in the real world, we are going to have to turn this on. Okay, so turn it on. Oh, look at that, the display shows. We can turn it off, we can turn it back on. All right, so in order for us to capture the single pulse, because okay, let's just have it as it is. All right, just out of the box, so to speak. Right, press the play button, and we have the simulation going on. So we have the beam going across the screen or the display. Now what happens if we press the button? All right, now we see a little bit of a pulse happening. We can kind of see it a little bit sometimes if we catch it at the right moment. See that? We didn't see it now. Now. All right, we saw it here. All right, so yeah, okay, that's cool. But let's just do something a little bit more. So I'm going to stop the simulation. All right, turn it off, turn it back on. Yeah, okay, whatever. So first thing, we're going to have to adjust the triggering on the scope. What the triggering is a bunch of circuitry inside the scope that makes the oscilloscope sensitive to the input signal in a certain way. And what we want to accomplish is, first of all, that the signal is visible, and then the signal is steady on the display. It doesn't shift from left to right, so we can actually take some measurements, and that's all we need to know at this point. All right, so so let's just get the trigger menu. I'm not sure if you can see it. I cannot zoom into that one. It's just multisim doesn't work that way. All right, so so we're going to click on the triggering menu, and things are going to change on the display. These are the soft buttons. Okay, so click on the trigger menu, and first we're going to change the mode of the triggering to normal instead of automatic. Okay, so no auto, turn it into normal mode here. Okay, so here's the soft button that operates that. There you go, we just clicked it into normal mode. Now what we have to do is we're going to select the position of the level of the triggering. It shows up here. You can't see it really, but if you operate this button, actually this number right here, channel 1, so we can select the source of the triggering. We can select the channel 1, channel 2, channel 3, channel 4, or external, but we're going to keep it on channel 1. But if you select the level of the trigger, we're going to make it just a little tiny bit above 0, and that basically should bypass all the noise, so we don't get the false triggering happening, because we're capturing a single shot, because we're capturing the pulse. 10 millivolts, you know what, that's okay, that's good. We're setting up a threshold, so ignore anything below 10 millivolts. Okay, now what we have to do is let's just position the beginning of the capturing, so to speak, towards the left, and that's this little triangle here that shows us when we're going to start drawing the waveform on it, and this is the button here we're going to operate. If we just turn it just like a knob, so click and hold We're going to move it all the way to the left, but so we can still see it. We can go off the screen, but we don't want to go off the screen. Just gonna go to right to the extreme left. Okay, so that we have selected, and we are pretty much trigger view here. That's good. Let's select this button right here that says single sequence. It's just like a single shot, right? And we're going to click on that, and then we're going to start the simulation, and this way we'll be able to capture that. In the real life, you don't have the simulation because you just exist. Really, you're not simulated. But but in this here, the sequence of events is that first you set up a scope in this case, and then you start simulation. Okay, so let's click single sequence. I just clicked on it. Start the simulation, and we're going to press the button, see if the scope is going to capture the pulse. Oh, it did. Something happened. All right. So we see a little bit of a spike here. Now we have this thing captured. I'm just going to move that towards the. So that was the probe blinking. All right. So we see something. What can we see now? We can adjust the seconds per division time span on this. This is the adjustment knob control. So right now what we can see is see what changes here. See, that number changes if we move it. All right. So it's 2 milliseconds per division. All right. So this is division. There's 1, 2, 3, 4, 5, and so on. That's one division. So each division represents 2 milliseconds. Now this is a spike here. So you see, we can magnify it by changing this milliseconds per division. Alright, so 10 milliseconds now, that gives us even smaller. Alright, but if we can do this, just keep going as far as we can. Oh, look at that, we can actually see it. And this is as far as we can go. Alright, we can go any further. 2.5, let's see here, where is it? Alright, 2.5 nanoseconds is as much as we can go. Alright, so we already see something. Now we are operating channel 1. So here's the positioning. See the vertical position of channel 1. So we can control that. We can select that. So now you see this little triangle here, this little arrow. That shows the 0 value of what we have. Right? Now, so we can just bring it right down, so we could see the whole pulse. Can we bring it to the very bottoms of the screen? Yes, the bottom. But let's just bring it to the one higher, so we could see things nice and clear. Right now, that was the time per division, and so that's the x-axis. Now the y-axis here is the volts per division. So what do we have here? Now this was channel 1. This is 1 volt. That means 1 volt per division. So each of that square, each division is 1 volt. So here's, if this one is 0, because we set it up, that little arrow here to be our 0, and our signal happens to go between 0 and wherever it is, right? So now we have 1 volt per division. So let's see how many volts are we getting. 1, 2, 3, 4, 5. Oh, isn't that special? All right, because we have 5 volt VCC, and this is the TTL family. Yeah, of course we're going to get this thing go up to 5 volts when this thing is high. So at this point we're having that little spike in form of a pulse. All right, now there's something more we can do. We can okay, so we can adjust the volts per division. If we make it more sensitive, then the signal is going to go off scale as far as displaying. It doesn't change the signal. The signal is captured. We're just kind of trying to adjust that to the point that we can actually see the whole thing the most comfortable way possible. And then we want to get it as bigger as possible without going off the screen. Right, so okay, that's as far as we can go. Now we can, for our comfort, we can also position this horizontally now. All right, because we use that horizontal position control to set up the triggering. So we're capturing this thing right from the beginning of the screen. But now once we have it captured, we can move it. So click on that and control. We can move that signal somewhere in the middle, or I'm just going to align this bottom where the pulse begins to happen with somewhere that I could make a reference to. So I'm going to bring it right up to here. All right, there we go. All right. What else can we do? We see a pulse, and we see that this is 2.5 nanoseconds per division. How many divisions does it take for the pulse to go from complete down to complete down again? So it's 1.5 times 2.5 nanoseconds. All right. So, well, let's see how much exactly is it. We can't magnify it anymore because that's as far as this oscilloscope lets us magnify things. But what we can do is we can click. There's a button that says Measure. All right, so we can click on that, and notice the soft menu here is going to change. So click Measure. All right, so we're measuring channel 1, and it says None. All right, so well. What happens when we click channel 1, source channel 1? Let's click Measure again to bring it to that point. We're going to click the cursor to bring up the cursor, and notice these two are going to light up. These two buttons are going to light up. So we click Measure, and then we bring up the cursor. All right. And now they haven't lit up yet, because what type of quantity do we want to measure? All right, again, I'm going to click Measure and Cursor. Source channel 1, so the cursors that we're going to bring here in form of lines, they're going to measure whatever is displayed on channel 1. We only use channel 1, so that just makes sense, right? So again, Measure, bring up the cursor, and what type of quantity do we want to measure? So here's the soft button, and we can toggle between things. As soon as you click on that, it shows up voltage. So it's going to have that. Now these two are already lit up. That means these are the two controls we're going to use. What we can do is we can click again and toggle. Oh, we can measure also time. All right. Okay. Let's see if we can measure time. So there's this button, and here's this button. Let's see what happens when we start turning them. Oh, we turn this one. Something happens. That's our cursor. Let's bring it up to this point right here. So, and now look at this cursor 1, because this is when we set up our simulation or our capturing. This indicates our 0 point. So if you bring that cursor to that 0 point, that's when we started capturing, because we brought it all the way to the left. The reference cursor is going to show you where it sits at. Okay, so look at this point right here. All right, this number is going to change. Actually, it's this one here we're looking at. All right, because this is cursor 2. This is cursor 1. All right, so brought it to 0. There, here's 0 at point. Now let's bring the other cursor from the other side. Right, so we're going to use the other control, and we're going to bring it right to where the pulse ends completely. There we go. So it sits at 3.77 nanoseconds with the reference to 0. And over here we have the delta cursor, the delta between these two cursors. So delta is the change, so the difference between these two. Of course, 3.77 minus 0, it is going to be 3.77. So it looks like it takes 3.77 nanoseconds from when the pulse completely begins and when the pulse completely ends. But let's see, we can also check how long this pulse stays completely high, right? So we're looking for 90%, but on this one here we can just approximate that. So we're going to bring the cursor right to this point where when this pulse is completely high. All right, so we're going to bring that to right here to this point, and we're going to bring that one to that point. Somewhere here. Okay, so that is the high portion of this pulse, complete high. So what do we have? Cursor 1 sits at 8.75 picoseconds. All right, so you can just tell that it takes 8.75 picoseconds to go completely high. All right, and then cursor 2 sits at 3.02 nanoseconds. So what's the difference between them two? It is 2.14 nanoseconds. So this time here, from here to here, is 2.14 nanoseconds. All right, so we have actually created ourselves a pulse, and we have confirmed that with the oscilloscope. All right, so that's as far as creating a pulse. So this thing is going from 0 to 1 when we press the button. All right, let's keep simulating that. Now nothing is going to happen because we already captured our shot, but we're just going to see the LED blink or the probe blink. All right, so that's our pulse. Okay.